SIP services will become mainstream after 2010 and will rapidly begin to dominate the world's telecom markets, and by 2012, ABI Research expects almost 1.2 billion VoIP users to be active, most users also subscribing to several forms of messaging and video sharing, driven by the interest in user-generated content. Additional services supported by SIP will include presence, click-to-dial, buddy lists, email and web access, which are assumed to be core services and will be included as standard in any service offering and bundled with broadband access. SIP has changed the face of VoIP, said Nabil Damouni, Director of VoIP Strategy in Intel Corp's Mobile Group. Moving forward, we will do nothing for H323 or Megaco. SIP has won. And one more reason for moving to SIP. The Technical Advisory Council to the Federal Communications Commission has recommended that the FCC set a date for the sunset of the PSTN, and this is said to be 2018. Users will benefit greatly from SIP, as many services that are cheap and feature-rich are becoming available. Users can benefit from the following: SIP providers offering voicemail, email, instant messaging and SMS, all for a small cost to the user. Presence-based services that allow users to control what colleagues can see about them and control over where calls are routed based on their present status. Mobility services, where calls can be routed wherever a user is, such as at home, the office, or on a Wi-Fi enabled mobile device. SIP needs to have some compelling reasons for businesses to adopt it. Luckily it does, and here are some of them. Pretty much all of the benefits that a user can get from a SIP provider can be made available to a business, such as mobility and the other services on offer. What will really be of interest is the introduction of SIP trunking that allows business to control their own environment yet take full advantage of SIP services. And utilizing SIP trunking can reduce support and maintenance costs, reduce the need to run separate voice and data circuits, eliminate any oversubscription of voice channels, why buy 24 when you only need 19, allow more flexibility in offering cheap DDIs to all users in the company, drastically reduce call costs for long-distance connections as the call can be carried across the internet for most of its journey, give flexibility in adding to or removing trunks as you need them without hardware changes, help facilitate multiple forms of communication such as video and instant messaging. Another great benefit is that a business can benefit from having multiple local numbers, all routing back to a single office, giving a larger impression of the company. So, what is SIP? Well, SIP is an acronym for the Session Initiation Protocol. That is a signaling protocol used for controlling multimedia sessions. It helps to establish user presence details and also locate users when they are using mobile as well as desktop devices. This is generally called SIP mobility. SIP can set up, modify, and tear down communication sessions. In this module, we will look at SIP components, how SIP works, and tell you what it can and can't do. More advanced features of SIP, along with its interaction and integration with other components and services, are discussed in the other SIP modules. Here's the official description of SIP from IETF RFC 3261 Session Initiation Protocol document. SIP is an application layer signaling protocol that defines initiation, modification and termination of interactive multimedia communication sessions between users. The SIP RFC can be found at the link displayed, and for more information on SIP and the IETF working groups, click on the link at the top right of this screen. Just like HTML and SMTP, SIP is a textual-based protocol that is based on the client-server model. Requests from a client device are sent to a server device, which then responds to the client. This request invokes a method on the server which normally makes something happen. SIP is a simple signaling protocol that relies on other established protocols to deliver the media and define which codecs to use. In this diagram, you can see that SIP lives at a layer above its transport protocol UDP that of course runs over IP. SIP carries SDP messages in its body to help describe the audio and media components of a session, yet it's up to protocols like RTP to deliver the media after DNS has found out where the destination is, of course. A couple of notes for you. SIP can also use TCP, and this is becoming more popular, especially with systems from Microsoft, and RTP, the real-time protocol, is explained in more detail in the SIP and VoIP module of this course. Okay, let's focus for a while on the clients and servers that you will expect to see in a SIP network. Here we will look at user agents, registrar servers, proxy servers, redirect servers, location servers, and SIP gateways. A user agent client, or UAC, is an application or device that acts on behalf of a user. The UAC will initiate a call, and the user agent server, or UAS, will receive the call. You will find that user agent clients are also user agent servers, so they can both initiate and receive calls. In a true SIP environment, you could configure two SIP devices to communicate directly without the need for intermediary servers. Let's look at what SIP actually does when a call is made. Once the user has dialed the destination number, the UAC will send an invite message to the destination device. If the destination device answers, it will return a 200 OK message to say that this has happened. The caller will then acknowledge this event. Now, voice, video, or whatever can pass between the two devices. When one device hangs up, it sends a bye message, which is responded to with a 200 OK message. The call is now complete. This is a diagram that shows you all of the major components of a SIP network. It is an overview, and all of these services will be explained in more detail during the course. Here we have user agents such as a SIP VoIP phone, a wireless PDA, or a soft phone. A SIP proxy to assist in the discovery and setup of the session between user agents. A SIP registrar that user agents use to register their current location on a network. A SIP location server contains the registered location information. Usually, the registrar and location services run on the same server. Another SIP proxy is used here to again assist in the session setup. More SIP user agents on the remote network. A SIP gateway will translate signaling, and probably media as well, so that SIP devices can communicate with legacy devices. A legacy PBX is shown here to demonstrate the connection between the SIP gateway and non-SIP devices. The SIP gateway also allows for connectivity through to the PSTN to allow communication between SIP and non-SIP devices. We can use URIs and URLs with SIP, so let's have a quick recap here. A URI, or Unique Resource Identifier, is a string that identifies some kind of resource. An example of a URI is graham@vocalitraining.com. This URI is an identifier, as we all know it's an email address, but does it tell you how to move emails to this address? It's just an identifier. A URL, or Unique Resource Locator, is a form of URI that not only identifies a resource, but tells you how to reach the resource. An example of a URL is http://www.google.com. This tells you the address of the web server at google.com and that a HTTP request should be sent to retrieve a web page. No web page is specified, so the web server will return the default home page. So we can see that SIP addresses are URIs with the same format as an email address, i.e. user@domain. The general form is user@host, where user can be a name or telephone number and host is the domain name or IP address. The main types of URI are service, device, and user. With a service, the URI could point to a conferencing unit that SIP users can reference and join. With a device, the URI represents a single device or application such as a laptop, PDA, IP phone, etc. With a user, the URI can be something static like graham@vocalitraining.com that can go on a business card. This URI, sometimes known as an address of record, will map to as many other SIP URIs as the user wants or needs. Again, SIP addresses are URIs with the same format as an email address, i.e. user@domain. Some examples are shown here. Have a close look at them and notice the ones that give an address but denote what kind of device is at that address. The goal of SIP addressing is to provide all users with a single URI or address of record, which when used in conjunction with DNS will reveal all the other information relating to that user or agent, things such as email address, video, data and voice capabilities, etc. In this module, SIP servers, we are going to look at the machines that work behind the scene in order to make things run smoothly. So, we will look at SIP registration, SIP re-registration, SIP proxy servers and why we need them, a SIP server in proxy mode, a SIP server in redirect mode, the different proxy server state types, and finally, location services. When a SIP device starts up, it sends its current address and location details to its registrar server. This server then updates the user's location in the location server. This can be some kind of LDAP-based server, even the Microsoft Active Directory. You may find that the registrar and location services are applications that run on the same physical server. And here you can see that once the client's details are updated, they can be contacted using their published address, which resolves to their current IP address. A registrar may require authentication first, but this is discussed more in the security module of this course.
When a SIP UA registers with a registrar, it tells the registrar about its feature capabilities. This is really useful information for SIP devices wanting to make contact with the UA. There are a whole list of features all detailed in RFC 3840 on the IETF website, but as an example, look at the contact portion of the registration packet sent by a SIP IP phone on boot up, where audio means the device supports audio, and mobility is fixed as it is a desktop device. It works at full duplex, and its description is Model 300. The actor element set to principal means that the device provides a way of communicating with the principal, usually a human. Methods will go on to list the SIP methods supported, such as invite, info, refer, etc. etc. More about these later.
Okay, what if this particular laptop is taken to a client site and turned on? Can people now call the soft phone using SIP? Well, on startup, the SIP soft phone will send its new address details to its registrar server that then updates the details at the location server. The old IP address that ends in 100 is changed for the IP address obtained at the client site, 10.56.10.1. Now, using the same SIP address of graham@vocalitraining.com, people can still call. You will encounter SIP proxy servers, as they are pretty much vital in a SIP network, so let's see what they do. A proxy server forwards a SIP request to the next server after working out which is the next server to talk to. It will interpret a request message and if necessary rewrite the message before forwarding it on. It can issue both requests and responses, so it is in effect a SIP client and server. A stateful proxy remembers the incoming request and outgoing requests. A stateless proxy forgets all information once an outgoing request is generated. And a proxy server can fork the incoming request to multiple locations if someone has multiple location registrations, i.e. office and mobile phones. So, why do you need a proxy server if UAs can contact each other directly? Well, sometimes it is only by contacting a proxy server that SIP signaling will actually be allowed to leave a corporate network. By sending all the SIP messages to the proxy will forward them on behalf of the UA. The proxy server may also be acting as the corporate firewall. For a UA to use a proxy, it needs to be programmed manually, or to get the information from another server, such as DHCP. In a large corporate environment, there may be a number of SIP proxies deployed. In this situation, a DHCP server can help by automatically configuring a SIP device with a preferred proxy for its own subnet, with alternate proxies in the case of server failure. The DHCP server can send these proxy details in either the DNS or IP address format in the DHCP option 120. You may see this trapezoid arrangement in a lot of documents regarding SIP, so we thought we'd put it here as well. It describes the basic core setup process when both parties work via their local proxy servers. A SIP invite goes out and hits the proxy that determines where the destination domain is from the SIP URI and forwards the invite to that domain's proxy, which then passes it on to the destination UA. The proxies will report back to the sending UA the progress of the core setup with messages such as 100 trying, and when the destination starts ringing, the 180 message is relayed back. A 200 message is sent on device pickup, which is relayed and followed by an acknowledgement. Once this has happened, voice can be transmitted. Again, you can see here if one device hangs up, a bye is sent and acknowledged. Okay, let's see if someone can find me on the customer site. For this example, the registrar and location services are running on one server. Linda calls Graham at vocalitraining.com and via DNS finds the proxy server at vocalitraining.com. Then her device forwards the first SIP invite to the proxy. The proxy sends a request to the location server for vocalitraining.com to find where my soft phone is currently located. The location server responds and the proxy sends a copy of the invite to me. My soft phone returns a 200 OK when I answer, which is passed to Linda, who returns an acknowledgement that is forwarded onto my soft phone. We can now start sending voice or video to each other directly. So, in proxy mode, all SIP messaging goes via the proxy, and remember this as we move on to the next type of proxy. Same thing again. Linda calls my SIP URI and sends the invite to the proxy running in redirect mode. The difference here is that once the proxy has found my location by using the location server, it sends the contact details to Linda's device. The invite is then reissued with my specific contact details directly to my soft phone. This means that the proxy is doing less work, and this type of proxy is often deployed when a high call load is expected. A proxy server can actually be of three types. First, stateless. This keeps no state information, and as soon as it has helped out a UA, it forgets everything about the transaction. These can cope with higher call loads than proxies that keep state information. Then, stateful. This kind of proxy keeps state information for the entire duration of a SIP session. This is useful for implementing extra services such as call forward on busy or no answer, and probably is the most common of proxy types. Finally, transaction stateful. This keeps all state information on all transactions that are pending. Once a session is established, the proxy forgets the state information. Let's move on to location servers. A location server is used by a SIP proxy server or redirect server to obtain information about a called party's possible location or locations. You will probably find it very hard to spot a location server on the network, as it is a service that is usually co-located with other SIP services we have discussed so far.
A location server will have a database to hold location information for SIP user agents, and this is kept up to date via the registrar service that is processing register and re-register messages from clients. The SIP proxy will then use the location service to help find the current location details of the destination SIP URI in a SIP invite message. Once it has its answer, it can forward the invite to the destination and tell the calling device that it is trying. Again, there are many developers and providers out there deploying SIP, and you may find that all of these services can run on one single server.
The location service may use a number of sources to do its job. It may have a local database that is provided as part of the location server product, or it may interface with more powerful databases, such as the Microsoft Active Directory, using the LDAP protocol. DNS can also be used, as it will store the location details of other servers in other domains that the location server may need to contact.
Let's look at an example. Linda's device sends a SIP invite to the URI graham@vocalitraining.com, which is forwarded onto the proxy that Linda's device uses. The proxy then needs to find the destination proxy at vocalitraining.com, so it sends a DNS request to its DNS server asking for the details of the proxies at vocalitraining.com. These are held in service records, and here you can see there is a record SIP UDP vocalitraining.com that results to the IP address 155.83.0.200. This is returned to the proxy that can now send the invite to the destination proxy. Don't worry about the complexity of the DNS record. This is explained in the enum and DNS module of this course. There's going to be a lot of configuring SIP clients during this course. In fact, in a few slides' time we'll be suggesting you download some and get configuring. But for now, we are just giving you the overview. Clients will vary from hard phones, soft phones on a PC, and of course VoIP apps on smartphones. What they all have in common is that they need to be configured with SIP parameters in order to work. Some will get their parameters via TFTP file downloads on boot up. Some may be able to get their details via configuration servers as set out in RFC 6011. And some will be manually configured. There are some basic elements that all clients need, and these are SIP registration server hostname or IP address. If using DNS names for the SIP registration server, then a DNS server address is needed for resolution assistance. SIP port number, usually 5060, a user account name, a password, and a SIP proxy hostname or IP address for when calls need to be made.
In this section, SIP messaging, we are going to look at SIP messaging in depth and concentrate on request methods, response codes, SIP headers, an invite example, a response example, along with specific points to note. SIP messages are normally requests and responses. The request from the client to the server, the response back to the client from the server. These requests and responses use different headers in the SIP message to describe the detail of the communication between the agents. To make SIP more secure, authorization and encryption can be used. These are discussed in the security module of this course. This is a quick run-through of the main SIP request methods. Most of them we will go through in more detail throughout the whole course, and for even more detail, please refer to the RFCs at www.ietf.org. Invite initiates a call by inviting a user to participate in a session. Invites can also be used for session modification.
An acknowledgement is used as a response to the 200 OK response that was the result of an initial invite request. A session should now be in place. An acknowledgement is only used with invite requests.
Bye is used to indicate termination of a call or session. Cancel is used to cancel a pending request. Register is used to register the user agent by temporarily binding the agent URI to an address of record, so the SIP server knows the location of the user agent. Options is used to find out what a server or user agent's media capabilities are, but does not set up a session. Info is used for communicating mid-session signaling information.
PRAC is a provisional acknowledgement and is only used in response to a 100-star response message. This is useful if an initial invite had no SDP body. Then after a 100-star response, the PRAC can include the relevant SDP detail. Each provisional response from a UAS, e.g. a 183 session in progress, is given a sequence number, carried in the RSEQ header field in the response. The PRAC messages from the UAC contain an RAC header field, which indicates the sequence number of the provisional response that is being acknowledged. For more information, please check out the RFC here, RFC 3262.
The subscribe method is used to request notification of an event or set of events at a later time. An example can be requesting a notification when another person's IM presence details change. Notify is used to notify that an event which was requested by an earlier subscribe method has actually occurred. It can also be used by a SIP server to notify a client of an event, such as the one in the attached trace, showing that a message has been left for the client. Don't worry too much about knowing how to analyze the trace, as we'll cover this in depth later. Refer is used to transfer calls and also to contact external resources. Update allows a client to update parameters of a session, such as the set of media streams and their codecs, but has no impact on the state of a dialog. The service method can carry a simple Object Access Protocol message as its payload. SOAP is a lightweight protocol that defines a framework for encoding request and response messages in XML. bNotify or Best Effort Notify is used by Microsoft's Link, LCS and OCS communication products. Unlike the Notify method, bNotify doesn't require a response, as applications may not need a notify response to a certain request, thus reducing SIP signaling traffic. This is important for deployments with large number of clients per Link, LCS or OCS server. Commit is used to confirm that conditions to make the connection have been met, such as quality of service requirements. The message method is an extension to SIP that allows the transfer of instant messages where requests will normally carry the instant message's content in the request body. SIP response codes are made up of 3 digits. The first digit in the code indicates the class of the response, and the other 2 digits are used to represent a reason or reason phrase. A 100-star response is an informational response. The request was received and is still being processed. A 200-star response is a success response. The action was received, understood, and accepted. A 300-star response is a redirection response. Further action needs to be taken in order to complete the request. A 400-star response is a client error response. For some reason, such as bad syntax, the request cannot be fulfilled at this server. A 500-star response is a server error response. For some reason, the server cannot fulfill a valid request. A 600-star response is a global error response. The request being made is invalid at any server. A SIP message looks very much like a HTTP message, and here is an example header from a SIP message. Okay, it looks complicated, but we will break it down and make it easy to understand starting on the next slide. Although SIP is a simple protocol, there is a lot of detail that needs to be worked through. Here we are going to break down the detail in a SIP invite message.
The header indicates the method type, and here we have an invite, the SIP URI of the target UA, and the SIP version, version 2.
Via shows the layer 4 transport protocol to use. Here it is UDP along with the IP address and the port where the response is to be sent back to. In this example, it is the external IP address on the sender's gateway, 82.36.89.78, port number 2051. Note that the branch parameter is used to uniquely identify this transaction and should not change. And our port will be discussed in the security module of this course.
From shows the details of the caller and the caller's SIP URI. In effect, it's the caller's caller ID.
To shows the details of the called party.
Call ID is a globally unique ID for this particular dialog. It will be the same for all request and response transactions within this dialog.
Call sequence is used to identify and order transactions, and in this example consists of a sequence number 1 and a method invite. Please note that each of the parties in a call will maintain their own call sequence numbers, and these numbers increment for every successive command in a call. The max forwards field is used to limit the number of proxies or gateways that can forward the request to the next downstream server. The numbers shown here will be decremented by each server that forwards the request. 70 is the recommended default value. Contact shows the SIP URI that can be used to contact this agent with subsequent requests.
User agent, in this example, indicates a Model 300 telephone, firmware revision 7.6.9. With some VoIP phones, you will see the model number and MAC address listed here.
If the accept field is not present, the receiving server should assume application SDP. It just so happens that this request includes the default content type. The allow field lists the set of methods supported by the UA generating the message. Allow events details some basic events that the UA supports. Here we can talk, put on hold, and refer or transfer a call or session.
The session expires header conveys the session interval for a SIP call. It is placed in an invite request and is allowed in any 200 class response to an invite. Here it is 3600 seconds or 60 minutes. It can be updated with update requests. If there is no session expires header, then it's implied that the session never expires.
Content type describes the body content, which is application, and the type, which is SDP for this particular example.
Content length is the length of the SDP body in bytes that follows what you see here.
Again, we are going to break down the detail in the message. This time the message is the 200 response to the invite you've just seen. This header indicates that we are using SIP version 2 and the response is exactly as it states, 200 OK.
VIA headers are inserted by servers into requests to detect loops and to allow responses to find their way back to the client via the aforementioned servers.
From again details the originating caller and their SIP URI. To details the original UA being called. C sequence is used to identify and order transactions, and in this example consists of a sequence number 1 and a method invite.
User agent, in this example, indicates a phone type of SIP phone with version 5 firmware and its MAC address. Call ID is a globally unique ID for this particular dialog. It will be the same for all request and response transactions within this dialog, and if you like, compare it to the ID in the invite message you've just seen.
In this example, the call info field provides additional information about the called party. Contact is a SIP URI that can be used to contact this agent with subsequent requests. Allow events shows some basic events that the UA supports. Here we can talk, put on hold, and conference a call or session. The Allow field lists the set of methods supported by the UA generating the message. The Session Expires field defines the session interval for a SIP session. Here it is 3,600 seconds or 60 minutes. It can be updated with update requests. Record route details are inserted by the proxy to force future requests in this dialog to be routed through the proxy. Here it is 217.10.79.23. Content type describes the body content, which is application, and the type, which is SDP for this particular example.
Content length is the length of the SDP body in bytes that follows what you see here.
Remember that in the SIP header, the via, from, to, call ID, and C sequence are copied exactly from the request. And note that the to and from are not swapped around in request and response headers.
At this point, if you need a break from theory and want to try some things for yourself, you could stop this module and have a go at Module 2, Wireshark. Now let's move on to the Session Description Protocol, or SDP. Here we will look at what SDP